So with a presentation called Making International Development Data Not Useless, I think one important disclaimer is merited. Words for me, means are my own. So with that small disclaimer, why did I name this presentation so negatively? I used to work with environmental data, which criticism that we always received was, oh, why is it so expensive? Why do you need to do this? Can't you get away with less? So it was always critiquing the data. Then, I was disseminating data and the nations, and all of you data scientists that criticize the data, saying, well, why isn't it more? Why isn't it better? So now we're in an NGO, we have to do a combination of those two problems. It's easy to say that haters are going to hate, but the truth of the matter is, there is things that we can do too. There are small things and there's big things. And R was one of the main things that I used to improve the whole data workflow. And that's what I'm going to present. So this presentation is going to be structured. First, I'm going to present some of the criticism that we received on why the data at the United Nations is inconsistent in 3 ways. And I'm going to show how the data is complete. And I'm also going to show, so as I present the problem, I'm going to show how R helps to find a solution. And then I'm going to show some other quick ones that we did with R. So, the internal inconsistency 1. Why don't the database and the reports match? Right? So we had a report, we would create a report after every big major data upload, and we would kind of think about it, come up with a nice report. At the same time, as we would go, we would be gathering information from the and uploading it into the database immediately. So obviously, as soon as the report falls out of sync, we can start getting complaints saying, oh, that's clearly a mistake, those are stupid. It's like, wow, obviously one is live, one is not. So obviously there's going to be some sync issues. But you might feel tempted to come up with kind of a reproducible workflow in which a report is automatically stitched. That's a terrible idea. Ask me about it every years. One of the things that we did to address this issue is we secretly had an R&D document that we would publish once a month in our internal team that would document what are the different ways that people are using the database, how are they using it, what's being used more, what variables are important, which ones aren't. I'm not going to go into what we did. It's not just for this one chart. It's basically a scatter chart where we're just kind of heat mapping stuff. And what we're doing, what this represents, is how many countries and how many variables were included in each query to the database. Okay? So that's it. It doesn't matter which countries and which variables. I just wanted to see what is the general usage pattern. Because we all assumed that people were down there in that cluster, a small number of variables, a small number of countries, and a very controlled query. But obviously, as soon as we did this, we found there's basically 3 user groups of people that are doing a query for one variable, all countries. Does that sound familiar to anybody? A variable, all countries? Or one country, all the variables. Which are the country specials? I want to know everything there is to know about Mexico, but here I want to know everything there is to know about what we're calling. As soon as we saw this, we knew that there was an opportunity. What we can do was provide a link, a dynamic link, from the database to the country profile. From the country profile to the database. The database to the country profile is easy because the folders were isocoded. So as soon as you structure the unstructured folder, it becomes very easy to do this in a very systematic way. To go from the country profile to the database is a little bit harder. We got to craft just under 1,000 queries. We created them in a semi-automatic way. But basically, we create these queries that queries the database for a country, a specific country, and a specific subject group. In this case, water resources, right? So as soon as we implemented this, what happened? This is what happened, what we had before implementing. And as soon as we implemented, we started seeing all these new clusters. Right? So what are these new clusters? These are clusters where people are checking a certain number of variables for the same one country, right? We see that the country experts that were doing queries for all the variables that you have for one specific country, that's ameliorated, that's sort of smarter. Whereas we start seeing all these clusters kind of coming up. You might say, as a criticism, well, all you did was provide a different environment for people to get data, it's not really revolutionary. Except for the fact that we also saw approximately double traffic to the database. So what does that mean? That means that there's people that were looking at the country profile that did not check the database. So now I'm providing the data, the relevant latest data, to a group of people that did not have access to it before. That's what. So again, just to underline what R did, it allowed me to observe constantly how the resource is being used. Right? So constantly observing, constantly monitoring. And then as a complaint comes in, there's some chances that there's a quick way that you can implement that allows you to add, in this case, transparency and convenience at the same time. Internal inconsistency type 2. Why is your data inconsistent from country to country? The answer is fairly obvious. When you have a database that includes Germany and it includes Rwanda, there's going to be some slight differences in data quality. And that leads to one of my favorite games that I used to play. Upload this data. Since this game is so much fun to play, we're all going to play it here. We're going to do a small role play. You are an analyst. You are entering national water data for freshwater withdrawal for the year 2017, correct? And I ask you guys, can you upload the data, yes or no? Okay. Freshwater withdrawal for the three top cities. Do I aggregate that all together and upload that? Who says yes? Who says no? Okay. Two. The total freshwater withdrawal for 2015 is this. Do I upload that data for 2017? Who says yes? Who says no? Okay. The total water withdrawal for 2017 is that. Do I upload the total water withdrawal value for freshwater withdrawal? Who says yes? Who says no? Okay, so you guys have thrown out 100% of the data that was very expensive and very difficult to gather. How long do you expect to have a job doing absolutely nothing? Right. The bottom line is this, right? So nothing is ever perfect. So we have to upload something. We have to do something. And just because most people were in the know, there were a couple of guesses here. And the point that I want to bring out is there's no right answers. We're not speaking about technical efficiency, correctness. We're not talking about anything like that. There is a definition. That definition is rarely adhered to. So where is the line drawn? There's no, it's basically a subjective thing. And the problem with that is that it causes stress, right? Because I'm making the decision on whether there's data reported for a country that's going to be used by all you people, all of your models, or not. So this is a very difficult situation. There's two solutions that we have. I'm going to call this one an anti-solution. I want to add more variables so that now, no matter what I get from the country, fits perfectly and is perfectly adhering to some definition, right? The reason why I call this an anti-solution, I mean, we did do that a little bit. As you can see, this is the water resource schema. It's already, it's fairly intricate, right? But we didn't take this any further because, obviously, if everything is specifically put in its own variable, when you guys try to do an analysis for total water withdrawal across the world, it's not going to match up. Because there's 17 different types of water withdrawals, and no data set is complete. If you pull up an A, you're going to write A and B. Right? Number two, it's overly complicated, right? What we have noticed is that in any case that we did do this, that we did push further into the variables, we're like, there's a nuance here that we have to clarify. Let's create a new variable. It's always misunderstood because people don't have the technical depth that we did when we made that decision. Because they don't know what we're facing, right? It's misinterpreted, it's a terrible idea. So basically it's a slippery slope. You do it a little bit, but don't go too far. This is not the solution to the problem of how to make countries the same. The solution that we found was through disclaimers, right? What kind of disclaimers? There's two. We add symbols to the database that specifies whether it's coming from a country, whether we messed around with a number, whether it's a model, whether it's an estimate, what is it, right? But the other thing, and this is what I really love, structured contextual metadata is the most interesting topic that you could possibly think of. Please ask me about that after the presentation. But basically, it allows me to put my criteria of acceptability into this database. Also, since visibility is one of the parameters in our internal database, we may reject a value and enter that as structured metadata, so that the next time that somebody says, oh yeah, this value is 13. I know why I turned that 13 value. Very, very useful for sanity and also for clarity. Most importantly, we provided this metadata available when you download the CSV file. And yes, it is a But the reason why we did that is because all of this pressure that we're feeling, whether we accept the value or not, we need you guys to use them, right? So this isn't something that R can do to remedy the problem. This is how you can fix your workflows to solve this problem. You need to feed the symbols in the metadata, right? You need to use the information that we are giving you. We're telling you the data is not perfect, and this is how. But how many people have taken in international data sets and not even looked at the notes at the bottom? Raise your hand. There's major problems with data sets, but it's good enough that I feel qualified to put that up. Right? You need to read over this thing. Let me give you a couple of quick examples. This is our beloved iris. There's an apparent outlier down there, right? Well, maybe if I inherited the metadata to this plot, I can see that the person that published that point says, actually, I think this is a daisy. Well, now that kind of clarifies whether this is an outlier or not, right? Take this one step further. What if you inherit this metadata to the residuals? It's not a model that you can fit. There's some areas that it's not particularly good the way that you want. Well, what if you can read the metadata and understand, yes, that's because these are incomplete. This does not have all the information, right? The last kind of inconsistency is external inconsistency, right? Why do different agencies have different values for the same variables in producing here? And the reason why, unfortunately, we might deal with different ministries, like one ministry, the Ministry of Statistics in the country, may have a different value than the Ministry of Agriculture. Unfortunately, that does happen. We have different mandates. Some union agencies are allowed to change values, some are not. They have to accept whatever the government provides, or not allowed. That's our choice is fine. Other ones get messed with, right? So there's things there. And there are nuances in the definition of each specific thing that it's a little bit more complicated, but there are some reasons, right? The important thing is that we do talk. We do kind of put the information together and try to kind of figure it out all together. So we do standardize and harmonize, and just to kind of separate and drive a point, and in honor of the fact that we have Jenny here, I hear that the best way to teach is by using Lego. So I said to use Lego to show the difference between standardization and harmonization. Right? So in standardization, we fit. We have a certain specific acceptance criteria. If the data does not fit, we throw it out. We only accept data that perfectly fits the mold, and if the data has a feature that does not fit, well then that feature is thrown out, right? Think CSV files. Whereas in harmonization, we're trying to get the usage of the data. If it's not perfect, well, I can manipulate it a little bit. If it's a little bit less perfect, I can manipulate it a little bit more, and then release the metadata what I've done. And if the data is really too bad, then I can throw it out, right? So we were talking about harmonizing when we're talking about cross-agency collaboration. And we try to do this. We try to do a huge exercise. We had a project. We created a huge database. We try to put all of the United Nations weather data aside, and we try to show it off in the portal. Unfortunately, we were underfunded, so we were faced with two choices. We could reduce the scope, or we focus on the portal first, both to get the interest and then develop on the back end. We decided to focus on the portal, thinking, let's get people who love the idea first. That's a bad idea. That was a bad idea because as soon as you have a relatively finished end product, there's such a funding requirement. They say, oh, but you're doing pretty good, so you're fine. We'll figure it out. And we're like, well, yeah, but the iceberg of work that we had to do behind is not. We're never going to get to it. So, fortunately, it was not a great initiative. But what we can do, this is how R can help in these kinds of scenarios. We are faced with the same situation. I think Shiny is great for quick prototyping. So we spend all of the budget on the infrastructure, the methodology, all of that hard stuff that is to be spent. Just prototyping Shiny is more than enough for folks to understand where you're going with it. You can build the nice fancy visuals, but don't make this results. It was really cool at the time. You can use Shiny, right? So that's how R can help with this consistency. It's the favorite. Why I saw a little data, bro. There's all your data. Your data's so sparse. Oh, where my favorite? It's January 1st. So where's all the last year's data? So there is something that we can do, right? As our people, we can go out and we can kind of create data. One of the last things that I did when I was at AO was I scraped Wikipedia, not deep Wikipedia. There's a difference, and we're just talking later. We scraped Wikipedia, we scraped the Google Map, Streetmap API. We created the biggest, to my knowledge, data set on dams. It was dirty, I didn't have time to finish it, but it was enough to harvest 5,000 dams for our workers. It was a win for us. So, really, really cool, really awesome. But this is not our bread and butter, right? Our bread and butter is questionnaires. Questionnaires for sensitive countries. Just to give you an idea of what that looks like, we created the SAMP plot. Of the last 5 questionnaires process, I'm not going to tell you when it was, because we're going to be able to figure out which countries it was. But suffice it to say that this is kind of part of the course. For each questionnaire, it's possible to get 107 data points, right? Of those 107, only 36 were filled in at all. Of those 36, only 31 were even logically correct. We're talking 1 plus 1 equals 7,000. Of those 31, only 13 had a valid reference. Every other reference was either circular or they were quoting us. Okay, well, of those 13, we had a very, very thorough quality control, and I'm going to talk about that. A very thorough quality control that we rejected 3 of those points. So on average, we're accepting 10 out of 107 data points. This is after spending a huge amount of money, time, and consulting, meetings with the governments, and I come up with 10 data points. And you guys decided to throw them all out. You can see kind of that that's the pressure, right? So we have to find a way of making those 10 data points work in any way that we possibly can. And this is the problem that we only had an access to. The World Bank released this chart talking about data deprivation in countries. You can see that even, you can see the time series that it is getting lower. But as far as 2011, we're still 77 countries that did not have the information that is required to kind of figure out what the problem is in order to help them develop. So this is the issue with the world, right? So how can R help with data scarcity? Can't. And then the reason why is because it's not that the data is the problem. It's not that our ability to process the data is the problem. The problem is the world. The world is, if you live in a place that is plagued by civil war, in which there's a famine, in which there's a local emergency, putting data is not up in the database is not the priority. The priority is to not die. And this is the reality of the world. So that's why the data is so sparse in the world. That being said, there are many other things that R can do and help with. So how can I generate interest using R? That means how can I convince people to do that? Everyone knows the 80-20 divide, the munching, blah, blah, blah. It's even worse in the United Nations because there's a huge amount of governmental work. There's a huge amount of email security contracts, finding funding, plus the bureaucracy of dealing with every government in the world, right? So already this is a huge, huge problem. So finally, when you do get to do that little effort, it's it's kind of not that much juice out of that specific lemon. So the solution is get more juice out of that lemon. So there's a couple of things that we can do with R, for example, just 3 of the examples of what we have done. We used for quality control, we used all of the river crossings in the entire world, right? So we do that just to validate the data that we had. But what stops us from then putting that together, coming up with a flow of every river in the world at the continental level? Just that we put something like this in front of somebody, now all of a sudden they're interested, right? Now all of a sudden they're like, oh, that's something new. Not only is it cool to look at, but it also kind of creates this kind of ad hoc categorization of countries from water towers to water sinks. This all of a sudden becomes relevant in analyzing national water policies, right? So that's something cool that happened and very quick to create. As soon as we create the aggregated cropping calendar for every country for the profile, what stops us from aggregating that information at a continental level and across crop chains so that in one succinct chart, we can see what irrigation is at a global level. What stops us from finding the stupid gist that somebody had released that allows you to create these weird looking sand keys and showing the water resources of each country, whether it's internal, whether it's flowing in, whether how it's flowing out, whether it's treaties. So now we can represent a country as an arrow itself. And what these three visualizations have in common is that it took days to prototype, weeks to implement to come to platform, whereas the data took months to years to calculate. So this is the power of art. This is really what lets you creativity apply. You have an idea, implement it, and that creates interest, right? That shows relevance. Reproducible objective analysis. This is kind of a huge product. Have people heard this, that the story is more relevant than the visualization or charts? When you see a picture and you hear a story about a specific beneficiary, that'll stay with you. You'll remember, that's memorable. Because when you look at a chart and I tell you 67% of statistics are from Gaussian, now you're not necessarily going to remember that 67%. You'll remember about that story of that person. Unfortunately, this leads to a lot of the time kind of valid and thorough quality concept analysis of the data is not really done. You can cherry pick, you can find out one really case scenario and put that in your web page. It's kind of a big pain point for people that kind of wants to implement projects in other places. So here's where it's time for me to introduce my own development. We have development area, we have data science, and we have field expertise. So if you're lucky, you can have unicorn squared. So you have somebody that can build that, but if not, you can easily find a team that can fulfill these three roles. This is what I see developer project that's successful. You start from the development research. Right? What are we trying to accomplish? What's the point that we're trying to get to? From here, you move into the data science realm, and you construct proper architecture. Not a one-size-fits-all, a database around that specific initiative. From there, you field validate, and you say, what's happening in the country? Will this database be acceptable? Does it have to be in English? Does it have to be in local language? Is biometric available, or is that connection my beneficial result? All of that stuff, right? Once you have your data, go back into the data science realm to do the full analysis of the data, right? With the raw data to understand the parameters of success or failure. It doesn't matter whether we win or we lose it. It matters to understand why, so that we can ultimately contribute that back to the development field and say, this is what went wrong, we know why. The initiative failed in general, but it was awesome in coastal communities. That allows us to grow and evolve and create better projects that ultimately do make a difference. Any one project is not matter. Not only once we do that, the theory itself is improved, but also we can implement and scale things properly if we know why we succeeded or why we failed. If I just put the number and says, yes, we succeeded, well, who cares? Here's another thing. Crunching data into aggregates is time consuming, right? So people don't have the ability to manage raw data. They say, oh, I'm spending all my time crunching these aggregates with stupid reports. It doesn't really work out for me, right? So this is where you're going to talk about the data world. It's no surprise to you guys that I have implemented this huge kind of complex workflow in which we absorb the entire chain. I'm going to talk about all of this. Basically, what we do is we have one command center that queries all of the databases, and that one command center is run on a timer and a wedding server. And the benefit of doing that I only have one run job to measure. And the way that I run each project is through a project file that sources things in. So this isn't a typical conversation, but I just have to show you this little bit. It's so awesome that the universe is awesome. If I wrap the source function around the safely command concur, then what I can do is basically say, okay, so for my projects, find ones which are completed, get the file name that runs each thing, and as soon as I do that, I can map safe source. And what that's going to give me is not only is it sourcing all the data in, but it's doing it safely, which lets me know if the run succeeded. That instantly can be pushed into a command center, which you can track which projects are failing and why. This command center is activated every 15 minutes, which means that automatically I know exactly which projects failed. I can send an email to those people. I can even automate that if I want. Send them an email so that it's not like a 2-month review process. Is your data operation? It runs every 15 minutes. It runs semi-automatically. People think that I'm like looking over them, saying, "How did you know? Like, why did you delete that thing?" It's like, "Oh, you're using it." Yeah, I was using it. Anyway, as soon as you automate this, obviously, senior management can get involved. You can produce information that's relevant to the subject experts. One of the things that we've done, we created this huge shiny dashboard that's kind of like a one-stop shop for all the corporate information. It really changes things. But the main thing is it provides a point where staff can look at the data. Right? They can look at the data and make decisions immediately. And that's what our is really transformation. The ultimate reason, however, why international development data is useless is because what have you done for international development, right? How many people have thought about donating some time to some UN organization or NGO? Right? It's super easy. If you don't know where to start, just Google this hashtag DO. There's internships that you can do. You can take a sabbatical. You can donate just a couple of hours per week. Find some way to help. Find some organization. Send an email to somebody, and they will probably tell you that there's something that you can cut off. I want to end on this. Pablo Picasso said that computers are useless. All they can do is give you the answers. So it's the question that's the important part. It's the question that's the relevant part. And I think that's the real power to data scientists. We know how to ask the questions. We know what to try to get from the system. So I think if we apply that to the NGO, it'll be a completely different situation. And speaking of questions, I'm going to take some rules. Sure, so secondary data, that we call it secondary data, so it's really, really useful. We typically, that comes within the development theory kind of sphere. An important part of a baseline is to figure out what is the situation in the country, and we do get the secondary data for that. Another kind of international data is, like a satellite imagery, remote sensing, that kind of information is available, without necessarily needing to go into the country. So that should be done. But I want to be very careful in saying that it's enough to do analysis with that. If you don't feel validated, you quickly find yourself calibrated with reality.
Thanks so much, Ryan. Question on data used to be like the background is data where.
Sure. At FAO, we're using SQL Server. In my company now, ACD at Evoca, we use Microsoft Web Apps, which are Azure SQL. They have access front-end. So we kind of use those because they're really easy to deploy. And it's important for us, for each of the projects that we have, that they have ownership of their database, which means that in a very limited amount of time, we have to train people on how to configure a database, database from scratch, completely being owners of that data, in addition to being analysts. So it's really, really challenging when we don't have the time to train. We're really kind of full database platform, so the access web apps is not sufficient.